Right now, above your head, thousands of worlds orbit distant stars. Some are frozen, some are burning, but a few, just a few, might be perfect for us. And if humanity truly becomes a spacefaring species, these are the planets we'll be aiming for. Humanity is preparing a foothold on the moon. For the first time in history, we're not just visiting our nearest neighbor. We're building the foundations of a long-term presence. But as incredible as that is, it raises a bigger question. What comes after the moon? Where do we go next? Colonizing space has always lived in the pages of science fiction, but we're now at the beginning of that story. Humans living on another world is no longer a distant fantasy. It's a real possibility within our lifetime. So today, we're looking at the planets, both near and far, that could one day house us. Mars is the obvious candidate. There's evidence of ice beneath the surface, and many scientists believe Mars once hosted liquid water, and possibly microbial life. But settling on Mars will require far more work than building bases on the moon. Terraforming, while theoretically possible, is still far beyond our reach. Mars is a long-term project, not an immediate home. So what about worlds beyond our solar system? Across the galaxy, astronomers have identified thousands of exoplanets, and among them, a handful sit in the Goldilocks zone, the region where liquid water could exist. These are the worlds that spark our imagination, the ones that make us wonder whether life might already be out there, or whether humanity might one day follow. Our journey begins just 4.2 light-years away, orbiting the closest star to the Sun, Proxima Centauri. Proxima b is an Earth-mass planet sitting right in the star's habitable zone. If it has an atmosphere, and that's still a big if, it could support liquid water. NASA climate models show that with the right atmospheric pressure, Proxima b could maintain oceans and even Earth-like temperatures. But this world lives dangerously close to a volatile red dwarf. Proxima Centauri unleashes powerful flares that could strip away an atmosphere over time. So Proxima b sits on a knife's edge. It could be a warm, oceanic paradise, or a barren, irradiated rock. Still, its proximity makes it one of the highest priority targets for future telescopes. Kepler 442b is a super-Earth orbiting a calm, long-lived K-type star about 1,200 light-years away. It receives almost the perfect amount of sunlight for liquid water, and its star is far more stable than the typical red dwarf. NASA lists it as one of the most promising rocky planets discovered by the Kepler mission. The downside is distance. At over 1,000 light-years away, it's incredibly difficult to study its atmosphere. But on paper, Kepler 442b checks nearly every box. Stable star, right temperature, likely rocky, and billions of years of potential habitability. TRAPPIST-1e is one of the most famous exoplanets ever discovered. It's Earth-sized, sits squarely in the habitable zone, and orbits a star so small that the planet receives gentle, even lighting, like a world locked in perpetual golden hour. JWST has already studied TRAPPIST-1e's atmosphere and ruled out thick hydrogen envelopes, which is good news. That means if it has an atmosphere, it's likely a secondary one, something more Earth-like. The challenge is that the TRAPPIST-1 star is active, and we still don't know whether the planet managed to hold on to its air. But if it did, TRAPPIST-1e could be one of the most Earth-like worlds in the galaxy. Just 12 light-years away, GJ273b is a super-Earth orbiting within the habitable zone of a relatively quiet red dwarf. It's larger than Earth, likely rocky, and receives a comfortable amount of stellar energy. Its star is older and calmer than many M-dwarfs, which improves its chances of long-term habitability. Scientists consider it one of the best nearby targets for future atmospheric studies. The biggest unknown is whether it has a thick atmosphere or a thin one, a detail that could make the difference between a living world and a frozen desert. Ross 128b is another nearby super-Earth, only 11 light-years away. What makes it special is its star. Ross 128 is one of the quietest red dwarfs ever observed. It barely flares, which means its planets are far less likely to have their atmospheres stripped away. Ross 128 bi receives a similar amount of energy to Earth and could have temperatures suitable for liquid water. It's close enough that future telescopes may be able to directly analyze its atmosphere, making it one of the most exciting nearby candidates for life. Gliese 667cc orbits a star that is part of a triple star system. Imagine standing on its surface and seeing not one but two additional suns glowing faintly in the sky. This super-Earth sits comfortably in the habitable zone and receives nearly the same amount of energy as Earth. Its equilibrium temperature is close to 4 degrees Celsius, chilly, but well within the range for liquid water. For years, Gliese 667cc was considered one of the best habitable zone planets ever found. The only drawback is uncertainty. We still don't know its atmosphere, and the system's gravitational complexity could affect long-term stability. But as far as potential goes, it remains one of the great early exoplanet discoveries. TOI 700d is one of the most promising Earth-sized planets ever discovered. It orbits a remarkably quiet red dwarf, a rarity, and sits in the conservative habitable zone. NASA's TESS mission found it in 2020, and follow-up studies show it receives about 86% of Earth's sunlight. Climate models suggest TOI 700d could support a wide range of atmospheres, from Earth-like to thicker greenhouse blankets. Even better, the system contains another habitable zone planet, TOI 700e, making it one of the only multi-habitable systems known. If we ever send probes to nearby stars, TOI 700 will be high on the list. Teegarden's Star B, a planet that consistently ranks at the top of habitability indexes. It orbits a cool, quiet red dwarf just 12 light-years away and has a mass almost identical to Earth's. Climate models show that with even a modest atmosphere, Teegarden's Star B could maintain liquid water across large regions of its surface. Its star is older and calmer than most M-dwarfs, giving the planet billions of years of potential stability. It's close enough that future telescopes may be able to detect atmospheric gases, maybe even biosignatures. If there's a world out there with oceans, continents, and perhaps life, Teegarden's Star B is one of the best places to look. These 8 planets represent the best of what we've found so far. Worlds that could, under the right conditions, support life. Some orbit calm, steady stars. Others cling to survival around volatile red dwarfs. Some are close enough to study in detail. Others are distant mysteries. But each one reminds us that Earth is not unique. The ingredients for habitability are everywhere. And as our telescopes grow more powerful, we find more and more. These 8 we discussed today aren't the only ones. There is so many more worlds that could be habitable and thousands, if not millions more waiting to be discovered. The universe is infinite, and the possibilities are endless. Thank you for watching the video. If you enjoyed it, please don't forget to like and subscribe. Have a great day.